So besides Klay Thompson, Ant has also been working with other NBA players. But to get noticed by more customers, the Chinese company will need to sign on even more of the bigger names to its roster of athletes and endorsements.
This is a nickel and cobalt battery, popular in electric vehicles in the US and Europe. And this is a lithium iron phosphate battery, also known as an LFP battery, which is popular in China. It has a shorter range, but it's cheaper to make, less prone to fires, and lasts longer. Both of these batteries were made by CATL, a Chinese company that's the world's largest EV battery maker. Of the 10 biggest EV battery companies, 6 are Chinese. China is the dominant force in EV battery production, while the US is deeply reliant on foreign batteries.
The US and China are in a David and Goliath situation when it comes to battery production.
We're comparing how the US and China stack up in the 4 main stages of battery production, from final assembly all the way back to sourcing the raw materials. China assembles more than 2/3 of the world's electric vehicle battery cells. US automakers lag far behind. Several companies have outlined plans to build plants in the US, but shifting battery production is difficult. Panasonic, a Tesla partner, learned this when it started building a battery plant at Tesla's Gigafactory in Nevada. Panasonic found it couldn't just import equipment from Asia. Different safety regulations and different operating conditions made it a challenge. It also had to train workers to make batteries, a finicky process where small mistakes can have major consequences. After years of its joint battery business operating in the red, Tesla and Panasonic's cell production has become profitable, and it's now a model for other automakers to follow. Other companies have found getting EV battery factories up and running takes longer than they expect.
Toward the end of the supply chain is where the US definitely seems like it can make the most inroads and then try to work its way back to traditional mining and processing from there.
It's the earlier parts of the supply chain that are more difficult. Before you can make finished battery cells, you need to build all the components that make it work: the anodes, cathodes, separators, and electrolytes. China is the global leader in producing these components. The US is far behind.
You're talking about working with very specific chemicals and materials and turning them into vital products. So there's a lot of safety testing and everything has to be very carefully done. So that's another reason China having years of leadership in this space is so critical, because they have the know-how, they're able to adjust to new technologies, and they've been doing this for a really long time. Both of those together make it a really Herculean task for the US to catch up.
The US government has invested billions in companies that are trying to do this domestically. But companies can need years to develop the technology and ramp up manufacturing. Automakers accustomed to slower development cycles are trying to revise battery development strategies in response to changing mineral prices and technology. For example, companies have 2 main choices when it comes to cathodes, the battery cell's most expensive component: nickel and cobalt, used widely in the US and Europe, or LFP, common in China. US companies have historically preferred nickel and cobalt batteries for their long range, but volatile mineral prices have led some automakers to turn to LFP batteries. While these batteries can't travel as far between charges, they typically last longer and have better thermal stability, meaning they're more resistant to heat. Some US automakers are particularly interested in them for entry-level vehicles.
Iron phosphate is in vogue now, but companies are really investing in next generation batteries as well. Companies are always innovating and trying to change battery chemistries. That's why getting a glimpse of the supply chain now and how it might change is really challenging.
Before you can make components like cathodes and anodes, you need to process and separate the raw materials that make them up. The US currently does little of this, while China is the world leader. And companies often have trouble building chemical processing facilities in the US.
The bureaucracy here between local, state, and federal regulations and then rules, all of that is a messy process that will take time to work through and a lot of resources. Then you have local opposition oftentimes to these facilities if there are concerns about consuming huge amounts of water or energy or even damaging the local environment. And the last big one is just labor and supply chain issues like we've seen throughout the coronavirus pandemic.
And then there's the matter of getting the raw materials. Most of the minerals in electric vehicle batteries aren't mined in the US or China. They're imported from countries like Australia, Indonesia, and Congo. China has strong relationships with these countries where it can get raw materials. The US is building new mines domestically and also building international partnerships, but both approaches have challenges. It can take up to a decade or more to get new mines up and running in the US, and raw materials are only useful once they can be processed.
US companies are also trying to go to other countries and say, look, we'll develop a mine here in a country like Ghana or in Africa, and then we'll ship that material to the US to be processed. The challenge is it's a lot more difficult to do even the processing facilities in the US. In the US, it's really difficult to get new mines built and permitted because there's a lot of environmental opposition and people just generally don't like mines in their backyard.
Some companies, though, are focused on an alternative source of materials. Instead of mining new materials, they're salvaging minerals from scraps and dead batteries.
In the United States right now, we have some lithium, but really no nickel, no cobalt, and on the grand scheme, relative to all the lithium that we're going to need, we don't have that much.
Ascend Elements is a U.S. startup focused on producing engineered EV battery materials. It currently operates a recycling facility in Georgia and is building a larger one in Kentucky that may cost up to $1.5 billion. The company says it can produce enough cathode precursor and active materials to equip 250,000 EVs per year. Recycling startups are among the more promising American battery materials suppliers, but they're far from matching the output of factories in China, the world's largest battery recycler. And they're years from contributing a meaningful amount of material to the market.
The recycled materials look exactly like a cathode material made from virgin material, which is, mined material. Send it to a third-party lab or whatever, you couldn't distinguish between the two.
Ascend Elements takes used batteries, discharges them, and shreds them to recover the critical components like lithium, nickel, and cobalt, while separating out materials like copper, aluminum, and plastic. They call the remaining powdery material black mass. Through this process, Ascend says it recycles up to 98% of the critical battery materials and does it with a significantly smaller carbon footprint than mining and traditional cathode manufacturing methods. It's currently focused on making nickel manganese cobalt cathode precursors and active materials. Recycling may not enable the U.S. to outpace Chinese production, but it could still be an important part of its domestic supply chain.
The question isn't really whether the US can catch up to China. It probably can't ever catch up really at this point, given how far ahead China is, but it will take many years for this to play out. A realistic goal is to just clean up the US supply chain so there is some domestic production of all these critical components. Right now, they're just basically at the mercy of China and these other countries.